So when we look at a graph, the basic radical graph, oh, it's being awesome. You don't have to draw this, I'm just reminding you. It was at 0, 0, 1, 1, 4, 2, 9, and 3, and it went like this. Do you agree? That's your basic radical graph. So what we know is it starts at 0, 0. It's up and to the right if there's no reflections, correct? If it's down or to the left, there's a reflection. We know that. If it's not on 0, 0, we know that there's been a horizontal or vertical translation, because the only way you can get off of 0, 0 is translating it up or down or left or right, because it's at 0, 0. Stretching does nothing. The other thing we need to note is that between the first point and the second point, I'm over 1 and up 1. Do you see that? It makes like a 1, 1 box. If my graph doesn't make a 1, 1 box between the first 2 points, there's a stretch. Okay? So how do we figure out horizontal and vertical translation? Is it on 0, 0? No. Then there's a horizontal and a vertical. If it's not up and to the right, there's a reflection. And if it doesn't make a 1, 1 box, there's a stretch. So those are the 3 things we look for. So the 3 things we look for when we are doing an equation is it up and to the right? If not, we have a reflection or a reflection. 2, a 1 by 1 box. If not, we have stretches. And 3, is it on 0, 0? If not, we have translation. Radical equations are honestly the easiest ones to do if you remember the 3 rules. So they want it in this form, y equals a, b, x minus h plus k. So y equals. First step, we look. Is it up and to the right? Is this one currently up and to the right? No, it's down and to the right. Correct? So if it's down, it actually went from up here to down here. What am I reflecting in? The x-axis. So where does my negative go with? The y. So I get a negative in front of my radical. Right? Okay, cool. Check. Box 1. We're done the reflections. What's the great thing about this? This is a square root function. Can I not just type it in, make my window be the same as that window, and see if I get the same graph? Yeah, I should know if I get these 100% correct or if I'm out to lunch. Okay? 2. Is it a 1 by 1 box? That looks like an absolute value sign. Looks like the absolute value sign. Is it a 1 by 1 box? Well, let's check. Is it? Yeah, so are there any stretches? Nope. Third question. Is it at 0, 0? No, it's not. It's 1, 2, 3 to the left, and 1, 2, 3, 4 up. Because we start at 0, 0 when we move, correct? So how do I put in 3 to the left? X plus 3. I technically don't need the bracket because there's no stretch, but I'm proving a point. You have to have a 1 in front of our x. And then I need to move 4 up, plus 4. That's it. If I type that in, I'll get that graph. Okay? Let's look at B. First question. Is it up and to the right? Is it going up and to the right?
Yes.
Yeah. So are there any reflections? No. Okay, next question. Is it a 1 by 1? Oh. It's not a 1 by 1 box. It's a 4 by 1. So which actually got longer, the horizontal stretch or the vertical stretch? Horizontal. It's stretched by how much? 4. So when it goes into the equation, it is? It's what? Okay, last question. Is it on 0, 0? No, it is currently 1, 2, 3, 4, 5 to the left, 1, 2, 3, down. This only works with radicals because they start at 0, 0. So if I want 5 left, I go x plus 5, 4 down, minus 4. No, 3 down, sorry, minus 3. Now here's the catch. They can actually not give us a quarter. We found a quarter, that's the easiest way. They could give us a vertical stretch. Remember, how do we do this with the radical? Instead of a quarter, how would I get it out to be a vertical stretch? How do you get anything out of a square root? You square root it. What's the square root of x plus 4? Or sorry, 1 x plus 4. My goodness, 1 quarter. Take the 1 out. What's the square root of 1? Square root of 4. Done. Take stuff out of a square root, you square root it. Take stuff, put it back in, you square it, right? So even if they ask me for a vertical stretch, it's way easier to find the horizontal on here. Now some people will say, but how do you get a vertical of a half? Well, if I went over 1, how much do I go up? A half. So that's why it would work. That's a lot harder to do though. I will always go a 1 by 1 box. I'll find the one that's easiest, and if I have to, I'll square root it to take it out, or I'll square it to put it back in. It's way easier. You try C and D. So let's look at the first one. Is it up and to the right? Is it up and to the right? It's up and to the left. So where was the reflection on? The y-axis. So I have a negative with my x, right? Okay, 1 by 1 box. Is it a 1 by 1 box? No, it's a 1 by 2. So what kind of stretch happened here? Vertical by a factor of 2. Okay. Is it at 0, 0? Nope, it's down 1. And 1, 2, 3, 4, 5 to the right. So I get x minus 5. And then minus 1. Now how could I put the 2 inside? What would it be? Yeah, minus a negative 4, because you bring it in, you square it. So what kind of stretch is that actually? Horizontal stretch by a factor of 1/4. Now some people might say, what if they give me both as, you can't, they're both right, right? Like they can't give you both as a multiple choice answer. Okay, D, is it up and to the right? No, it's actually down and to the left. That's the easiest one, because they're both reflected. So you put negatives in both spots, right? You don't even have to think about it. So it's down and to the left. So I would get y equals negative, negative. Okay, is it a 1 by 1 box? No, it's a 1 by 4. So what kind of stretch is it? Vertical by a factor of 4. No flipping y's, so y's always stay the same when you say them. Put them in an equation, put them in mapping, they're the easiest. Okay, transformation. I'm 1, 2, 3, 4 right, and 1, 2, 3, 4, 5 up. So I go x minus 4 plus 5. How can I get that 4 to go inside? Square it. So, or y equals negative. The negatives don't move, just the number. Negative 16 x minus 4 plus 15. So that's a horizontal stretch by a factor of what? 1/16. And how can I prove that? Well, if I move up 1, then it would be over whatever. Oh, that's not where I am. Whoa. What? Yeah, it's this way. This would be 116. I started here. 15. I don't know. Pray for me? I don't know. And that's how you get errors on a test stupidly. I don't know how that transferred from a 5 to a 15. I took the one from above, joined them. Took 2 digits. I don't know. Things happen. Did I say 15? Did I say 5? We'll have to roll back the tape. Did I say 15? Ah, dang it. All right. New notes for today. So, there are only 2 radical notes. That's it. In the chapter, there's 2 lessons. That is it. In this chapter, 2 lessons. Rationals, 2 lessons. Other functions, 3 lessons. That's all we have left, 2 and 3. Now, radicals, what you have to understand is there's 2 lessons and you have to tell the difference. One of them is, I give you a radical equation, you tell me crap about it. So, for example, we did these yesterday. If I gave you like y equals, don't write this, just proving fact, y equals root x, and then y minus 7 equals 3 root x plus 6, oh, we'll make it harder, 2x plus 6, and then I ask you transformations, I ask you domain, I ask you range of the transform graph, I ask you x-intercepts, y-intercepts of the transform graph, from a parent function to the transformed graph, correct? That is lesson 1. You have to be able to tell the difference between the 2 lessons, people get them mixed up. Lesson 1 is I give you a parent function, square root x, and ask you crap about the transformed one. Okay? Lesson 2 is today's. Lesson 2 is this. Lesson 2 is I give you a function. Oh, I forgot we didn't have a marker, I guess. We did before? We do not now. I give you a function. It's either linear or quadratic or some other random function, but usually linear or quadratic. And then I ask you to take the square root of it. So the function I give you, does it have a square root sign on it? No. I make you take the square root of it. Those are the 2 lessons. 1, I give you the parent function radical, I make you transform it, you tell me crap about the graph. Okay? Or I give you a straight up function. A function just passes the vertical line test. I can give you any function. Most of the time it's linear or quadratic. And you take that linear or quadratic and you root it, and what kind of graph do I get from that? The original graph I give you is not rooted. Okay? So, we're going to flip to example 7 so I can prove a point. We'll come back in a second. Way ahead. Oh, I was there. So, instead of giving you the equation, I give you actually the graph. So I say, given the graph of y equals f of x, I want you to now sketch the graph of y equals root f of x on the same grid. Every single person is putting down their pencils and pens. You're finding example 7 and you are listening. This is a crazy easy lesson that everyone gets wrong. Because we don't understand. We just try and memorize steps Mrs. Lepp gives me, and then I bomb it because I don't actually understand it. And if you don't understand it, you're pooched in 30-1, right? Understanding is the key thing. Sheer memorization will get you about a 50 or 60. Understanding will get you the higher marks. Okay? So, we're going to try and understand this one. What the heck is f of x the same as in grade 10, so your teacher told you so that you didn't have a panic attack? It's just the same as y, right? Well, hello, it even says y equals f of x, right? Does it not? So f of x is literally just the y's. We agree? My x in this case is whatever the heck x is. We did this in grade 10. You're not writing anything. You are not picking up a pencil. You are paying attention. If I gave you f of 2, that meant that 2 goes in for all my x's, right? When it's in the bracket, that's what the x is. We agree? Okay. So, what am I doing here? Well, if I look at my x's, my x is x here, is it not? What is my x here? X. Has my x changed? My x's are consistently the same. This one here, I have a y. We agree? To get my new graph, what am I doing to the y's? I'm square rooting them. Did I change my x's though? I have an x. I have an x. Did my x change? No. I am, however, taking my y's from the original and I'm doing what to them? Square rooting them. That is all I'm doing in this lesson. I'm keeping my x's because they didn't change, right? X, x, they didn't change. X, x, nothing changed. But I went from f of x to root f of x. So how am I getting my new graph? keeping my x's, square rooting my y's. That is the lesson. Literally, I'm not even joking. That is it. Okay, so we're going to try it on here. I keep my x's, I root my y's. That is it. So we're going to look at this point. I'm going to pick this point here. I keep my x, I root my y. What is my x at this point? It's -4 and -7. What would my new point become? -4 and the root of -7. Does anyone see an issue here? Can't. That's going to go away. My mapping is x, y. Becomes x root y. That's all these are. That's it. That's gone. That doesn't appear on the new graph, does it? Because you can't take the square root of a negative. So all of these y's, oopsies, didn't know I had an eraser there. You know, keeps me guessing. You can pick up a pencil now. All of these y's down here. What are all of these y's? What do they have in common? They're all negative. If I take the square root of them, what's going to happen to them? Error. So they're going bye-bye on the new graph. We don't have them. See you later. We don't like you. Go away. What about these ones? Same thing. See ya. Don't want you. Rooting you doesn't work, right? Now we just need to do the rest of the graph. What happens when I take -3 and 0? So I have -3, 0. It's going to become -3, the root of 0. Wait a second. What is the root of 0? 0. Is this point changing? What's the definition of a point that does not change? It's an invariant point. So I'm going to make these ones red. So this one here will stay invariant, correct? So will that one. Will it not? Is there any other y values that when I root them, they stay the same? 1. When I square root 1, I get 1, correct? So this one here is at -2.8 or whatever, and 1. Well, it's going to stay -2.8 and 1. And so is this one. So I'm going to say invariant points when y equals 0 and y equals 1. Now, if you understand why the heck they say invariant, you're not memorizing. You're not trying to memorize, oh, when y is 0 and y is 1, it's invariant. You don't need to memorize that. We're literally keeping our x's, rooting our y's. When we root a 0, it stays 0. When we root a 1, it stays 1. That's why they're invariant, not because I'm memorizing 0 and 1 are where the invariants lie. Memorizing scares me very, very much because you'll start mixed-meshing memorizing. Yeah, it's scary. So all we're literally doing is we're taking our x's, we're keeping them. We're rooting our y's. That's what it told us to do in that equation above. We're just doing what it told us to do. What happens when you root a decimal? So square root 0.5. What do you get? 0.707. 0.7. It actually goes up. It gets bigger when you square root a decimal between 0 and 1. Square root 0.25. What do you get? So it's always getting bigger when you square root between 0 and 1. When you square root any number above 1, it gets smaller. Square root of 4, 2. Square root of 9, 3. Square root of 16, 4. Right? When you square root numbers greater than 1, they will get smaller. But any number between 0 and 1 actually grows. Because when you square root a decimal, it gets between 0 and 1, not just a decimal. Between 0 and 1, it grows. So if I want to sketch this graph, I go to where the heck x is 0.5. So x is 0.5 here at that x, or sorry, y is 0.5 at that x, whatever that is, -2.9. And I go up and just draw it at 0.707. So it just goes a little higher. So 0.5 just goes up to 0.707. Or 7 something, whatever, goes up there. So 0.5, I just draw a little higher. So I take that same x value and I just go up to 0.7 and I just sketch them, right? Now, could I sketch every other point on there? Sure. I could go to, okay, this one's at -2 and 5. I don't want red. This one's at -2 and 5. So it's at negative 2 and 5. What's it going to become? Negative 2 and? Yeah, 2.2 something, 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 because it's root 5, right? So now I'm going to redraw that one. Negative 2 and 2 point, what'd you say again, sorry? 2.23. So somewhere like here. Wait, this one's going to become the same. Why is this one doing the same thing? Yeah, because it's 2 and root 5, right? That's going to be my new point there. Okay, this one's at 8. This one's at negative 1 and 8. I pressed purple. So I also have negative 1 and 8. What's it going to become? Negative 1 and root 8, which is 2 point something, because root 9 is 3. 2.82. So now I'm at negative 1 and 2.82. And then I'm at positive 1 and 2.82 because it's the same thing. 0 and 9, where the heck does that go? Yeah, 0 and root 9, which is 0 and 3. Curves a little out, comes up here, comes back down. That's it. Is that crazy hard to do? No, you keep your x's, you root your y's, that's it. So all the negatives are going to go bye-bye. So what's my domain of g of x? I should take these blues off because this looks like the graph's down here. So those went away. So what's the domain of this g of x graph, this blue graph? X such that, what's it locked between? Negative 3 and 3. Why is it equal to? Yeah, because it's on that point. You can take the square root of 0, right? And then what's the range of this one? In set notation, we're between what and what? 0 and y and 3. You try the next one. So this one, the whole bottom goes away. This will stay at zeros, because that's an invariant point, and 1 is an invariant point. So I plot them right away. I immediately go there and just put dots on them, because those babies aren't going anywhere, right? I go to my 0.5 and I draw it a little higher. So wherever 0.5 is, I go to that exact same x and just draw it a little higher. So I put it like here. Because it just curves out that little bit. That's what they're going to look for. They're going to look for that little out curve, knowing that 0.5 actually goes a little higher. Then I like using ones that pass through, so I'm going to use this one. But you can use anything you want. You could use this and 2, this and 4. It's like, so I can go like this, and I can go, hey, this is y equals 4. Why do I like y equals 4? Because the square root of 4 is 2. And it keeps the same x, correct? So it's just like, when I do these ones, I treat it like there's like a little like raindrop falling completely straightly down. Straightly down. Yep, that's why I do math. All right, straight down to 2. So like a little raindrop is falling down, falling down, falling down, falling down. Like straight raindrop. That's not a straight one. Pretend it's straight. And then at 2, I draw a dot. Because you keep the same x. Your y just changes. So it's a raindrop dropping down, because anything above 1 will get smaller, right? Square root of 4 is 2. Square root of dying is 3. So I go to where 4 is again, and I have my little raindrop fall straight down. Pretend this is straight. I can't. It seems today I'm so a little crazy. And then I go down here, and I make a 2. Where else could I do that easily at? 9. 9 is another good one. Would you keep the raindrop? Would you keep that little red raindrop in your graph? No, that's me just showing you a visual. You know what I mean? Like you don't keep that. So like I would go back and I'd be like, Okay, before the test, before I'm done, okay, I'm gonna get rid of my raindrops. Okay, and then we're gonna go here, and I'm gonna go to 9. 9 is here. Oh boy, this is the distance. This is not gonna be straight. Pretend it is. Ooh, I'm gonna use this. All right, still not gonna be straight. Oh, I'm gonna make it thinner. Oh, it's as thin as it gets. Well, there we go. Here's my raindrop. Oh, this is terrible. These are really big raindrops. Really thick raindrops. I should just have drawn it. Okay, I regret that decision. So it's raining, it's pouring, the old man is snoring. I hit 3 and then I make a blue dot on it. There we go. It's raining, it's pouring, the old man is snoring. I am monotone like a fox. Here we go to 3. Then, everyone draws this beautifully, and then this is what I get, and it makes me so sad. Okay, we connect, and then, sure, cool. Can you do that? Is there even any graph that you can draw that to? No, you've just completely lost marks. There's no graph to do that to. So actually, that's worse than just giving it a little arrow at the end, because that's all you can do. I don't know where this is going. Poof, little arrow. See? And then I go this. Poof, little arrow, because I have no more graph to actually draw a graph to, right? So what's my domain? X such that I cannot put these together because one's going this way, one's going this way. If you draw an X in between with like the losers with the less than thens, that's when X values are sitting in between two X values, right? These you have to draw separately. Because when you draw them together like that, you're saying and. This one I have to say, okay, well, X can be less than or equal to 3, or, not and. There's no numbers in the world that are less than or equal to 3 and greater than 3. Like, there's no such thing. It doesn't exist. So I say, X such that X is less than or equal to 3, or X is greater than or equal to 3. It has to be an or when they're out in different directions. In interval notation, it would be negative infinity to 3, square, right, negative 3, sorry, square bracket, union, that's what or means, 3 to infinity. My range is easier. What is my range? Greater than or equal to 0. Finish this. These are matching. And this. How can I go about doing this one? Could I sketch the graph and take the square root of all the y's? Sure. Could I just type this in as well? This is actually easier. I can literally type that in. Why couldn't I type the previous ones in? I didn't give you an equation, did I? I just gave you a graph. If I give you an equation, can you just type that in and then give me the domain and range off of this like a normal? Like yesterday? Yeah. So you're doing example 5 and 6. One thing before we go, I want this one. For each point on the graph of y equals f of x, determine the corresponding one on this. What do I do when I go from this to this? Keep my x and do what to my x and do what to my y? Square root it. So what's this point going to become? 3, 0. Because what am I doing? Square rooting the 0. Remember, x, y becomes x root y. What about this one? Negative 5, 5. What about this one? 9 and root 15. It says here is 10th where necessary, but I'm just going to leave it like that. What about this one? You could say not possible. No coordinate, no such coordinate. Can't square root of negative? It's a, yeah. Well, it wouldn't be a solution. Solution, no